여기 제 얼굴도 한번 살짝 잘 나왔는지 모르겠는데 잘 나와야 되는데 저도 이렇게 한컷 찍어봤습니다. 그 중력하고 상관없이 요렇게 여기 따라가서 가야 될 거 아니야. 따라서 360도구나 이렇게. 그러면 요것이 여기서 비행기 머리가 이렇게 떨궈줘야 돼. 당연히 여기서 이렇게 변한다고. 높이가 머리를 떨궈주니까 이렇게 가지는 않을 거 아니야. 이렇게 해서 이렇게 차이 나는. 아니 뭔 놈의 중력이 각도에 따라서 이게 바뀌는데 비행기가 처음에 각도가 이게 못 알아듣는 애가 끝까지 못 알아들을 것 같은데 요 지금 기울기가 요 각도에 따라서 이렇게 바뀌잖아. 그래서 이렇게 나누면 또 안 바뀌고. 이게 뭔 중력이야 이게. 무슨 이 중력이 잡아 끌어서 이 기포방울을 가운데다 놓는다 말도 안 되는 소리를 하는 거죠. 공간이 어디에 있든 간에 수평만 보는 거예요. 수평만.
Have you ever wondered how your phone manages to know what direction you're holding it? It's using a device called an accelerometer. It works by sensing the acceleration of gravity, and then you can calculate what direction the phone is facing. But how does a piece of electronics sense something mechanical like acceleration? The answer is MEMS.
이륙을 하면 이게 이렇게 올라가게 돼 있죠. 이렇게. 당연히 중력하고 상관없이 올라가는 거예요. 이게 무슨 기계로 이게 지금 체크되는 게 무슨 중력이 잡아 끌어갖고 모든 게 뭐 중력이 다 알아서 해준다라는 식으로. 그만큼 이제 참 무서운 겁니다. 사람이 이렇게 참 무식하게 갇힌다라는 것이. 시속 800km, 마하 뭐 800km, 900km로 나간다 그러면 매 7분마다 앞머리를 떨궈줘야만 이렇게 그러니까 둥그런 지구에서 나르는 게 맞는데 절대 몇 시간이고 가도 이게 바뀌지가 않습니다.
I'm just doing a short video to answer a question I get asked all the time, and the question is, does a pilot have to pitch the nose of his aircraft down as he's travelling across the Earth, and that is to compensate for the curvature of the Earth? Well, the answer is that the aircraft does in fact pitch down as it travels across the Earth, and no, the pilot doesn't really notice it because the rate of pitch down is so slow that it's basically imperceptible. And what I'm going to look at is how we actually fly an aircraft by reference to the flight instruments. This is what's called a 6-panel, and it's basically a version of what you'll find in just about every aircraft. Now, when you're hand flying, it's just a constant dynamic process. You're scanning the instruments, you're making minor corrections all the time. Literally every minute you're making maybe half a dozen or more minor corrections. Now, travelling at like when you're driving down the road. You're driving down the road, even if the road is straight, you don't just hold the steering wheel straight, you're making just the tiniest adjustments all the time to keep the car in the middle of the road. And that could be due to maybe a few bumps in the road, or perhaps a bit of side force from wind. In the aeroplane, there's any number of reasons that your altimeter can just start to fluctuate up or down a little bit. Very slight air pressure changes or turbulence. When the autopilot is flying, it's making numerous tiny corrections all the time. 10, 15, 20 corrections every minute that are so small, they're not perceptible, and they're just holding the altimeter steady. You barely even see the vertical speed indicator move. So we're making tiny corrections all the time to compensate for the curvature of the Earth. The nose has to only pitch down 1 degree in 8 minutes. In that 8 minutes, the autopilot has probably made well over 100 or maybe even 200 individual slight corrections. You know, slight corrections of 0.1 of a degree or 0.2 of a degree. So yes, so the reality is, as the aeroplane flies across the Earth, it is pitching down. The pilot's not conscious of it because he's not even thinking about it. The rate of movement is so slow that it's negligible compared to the smaller, more frequent corrections that you need just to maintain altitude, just to maintain the vertical speed indicator steady. And obviously when the autopilot's doing it, pilot doesn't even have to touch the controls. You virtually don't see any movement in this artificial horizon. In a head-up display, if you look carefully, you can see tiny deviations in the pitch.